Good morning students. In previous class we have discussed about how to do prime factorization of given number. Today we will discuss exercise 3.5. Exercise 3.5. Question number 1. Which of the following statements are true? Question number A. If a number is divisible by 3, it must be divisible by 9. Answer is false. Reason, one of the example, 6 is divisible by 3, but 6 is not divisible by 9. Question number B, if a number is divisible by 9, it must be divisible by 3. Answer is true. Since 9 is equal to 3 into 3, hence if a number is divisible by 9, it will also be divisible by 3. Question number C. A number is divisible by 18 if it is divisible by both 3 and 6. Answer is false. One of the reason, since 30 is divisible by both 3 and 6, but it is not divisible by 18. Question number D. If a number is divisible by 9 and 10 both, then it must be divisible by 90. Answer is true. We know 90 is equal to 10 into 9 and 10 and 9 are co-prime numbers. So, if a number is divisible by 9 and 10, then it is divisible by 90 also. Question number E. If two numbers are co-primes, at least one of them must be prime. Answer is false. One of the reason for, as the example, is since 25 and 16 are co-primes and also they are composite numbers. Question number F. All numbers which are divisible by 4 must also be divisible by 8. Answer is false. One of the example as a reason, 12 is divisible by 4 but it is not divisible by 8. Question number G. All numbers which are divisible by 8 must also be divisible by 4. Answer is true. We know 2 into 4 is equal to 8. Hence, if a number is divisible by 8, it will also be divisible by 2 and 4. Question number H. If a number exactly divides two numbers separately, it must exactly divide their sum. Answer is true. This divisibility rule we have learned in previous classes. Number I, if a number exactly divides the sum of two numbers, it must exactly divide the numbers separately. Answer is false. One of the example as reason is given. We will take 7 and 5 and their sum is 12 and 2 divides 12 but it does not divide 7 and 5 separately. So answer is false. Prime factorization can be done by factor tree method also. In question number 2, 2 factor tree of number 60 is given. We have to find out the missing number on its branches. Question number A, it is given 60, product of two numbers 6 and 10. And 6, we know it is 2 into 3. So, 2 is here, 3 will come here. Similarly, 10 is 5 into 2, 5 is here and 2 will come here. Question number B, 60, it is written 30. So, we know. Question number A, 60 is product of two number is given 6 and 10. And 6 we know 2 into 3. So, 2 will come here. It is already given in the question and so 3 will come here. Similarly, 10 is 5 into 2. In the question already it is given 5 here, so 2 will come here. Question number B, 60, below 60, 30 is given. We know 60 is equal to 30 into 3. Now 30, below it is 10 is given. We know 30 is equal to 10 into 3. So 3 will come here. Similarly, 10 in both question mark, we know we have to find out the prime factors and 10 is equal to 5 into 2. We can write 5 and 2 here. Similarly, you can write 2 here and 5 on the second place also. Number 3. Which factors are not included in the prime factorization of a composite number? Solution. 1 and the number itself are not included in the prime factorization of a composite number. Because in prime factorization, we are writing the number as product of its prime factors. So, 1 and the number itself will not included in the prime factorization of a composite number. Number 4. Write the greatest 4-digit number and express it in terms of its prime factors. Solution. We know the greatest 4-digit number is 9999. Here the prime factors of 9999 is found out by division method. First we have tried to divide by 3. Then we got the quotient 3333. Then it is again divided by 3. We got quotient 1111. It is not divisible by 2, 3, 5, 7, etc. Then it is divisible by the next prime number 11. Then we got the quotient 101. Again 101 is a prime number, so it will be divisible by 101 only, and we will get quotient 1. So prime factorization of 9999 is equal to 3 into 3 into 11 into 101. Number 6. Find all the prime factors of 1729 and arrange them in ascending order. Now state the relations, if any, between the two consecutive prime factors. We have to first find the prime factors of 1729. Then we have to find out any relation between its prime factors. Solution. Given number is 1729. We have to find out the prime factors. So by division method, we have to divide the given numbers by prime numbers. So it is not divisible by 2, 3 and 5. Next prime number after 5 is 7, and it is divisible by 7, and we will get quotient 247. 247 is not divisible by 2, 3, 5, 7 and 11, and it is divisible by 13, and we will get quotient 19. And 19 is a prime number, so it will be divisible by the number itself, and we will get the quotient 1. Hence, the prime factors of 1729 is equal to 7 into 13 into 19. Now, we have to find out the relation between consecutive prime factors. First, we will take 7 and 13. 13 minus 7 is equal to 6. Next, 19 minus 13 is equal to 6. We see that the difference between two consecutive prime factors is 6. That is the relation between two consecutive prime factors of given number 1729. Question number 7. We have to verify with example whether the product of three consecutive number is always divisible by 6. Three consecutive number means three continuous number. Example 5, 6, 7, 10, 11, 12, etc. Question number 7. The product of Question number 7. The product of three consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. Solution. Take three consecutive numbers. Consecutive numbers here means three continuous number. So we will take three numbers as 3, 4 and 5. And we have to find out their product. Product of 3 into 4 into 5 is equal to 60, and 60 is divisible by 6. Similarly, you can try more three consecutive numbers, find their product and try to divide it by 6 and verify it. Question number 8. The sum of two consecutive odd numbers is divisible by 4. Verify this statement with the help of some examples. So, two consecutive odd numbers. Solution with example number 1. Let us take two consecutive odd numbers 9 and 11. Their sum is equal to 9 plus 11 is equal to 20, and we know 20 is divisible by 4. We will get quotient 5. Similarly, another example 25 and 27, they are two consecutive odd number and their sum is 52 and 52 is divisible by 4. Question number 9. In which of the following expressions prime factorization has been done? Question number A. 24 is equal to 2 into 3 into 4 is given. Here 4 is not a prime number. So the prime factorization of 24 is not done. Question number B. 56 is equal to 7 into 2 into 2 into 2. Since 7 and 2 are prime numbers, hence the prime factorization of 56 has been done. Question number 10. Determine if 25,110 is divisible by 45. Solution. 45 is equal to 5 into 9, we know. And we know if two coprime numbers are divisible by a number, then it is divisible by 45. Here 5 and 9 are coprime numbers. So we have to check whether the given number is divisible by 5 and divisible by 9. If it is divisible by 5 and 9, then it is divisible by 45 also. First we have to check whether the given number is divisible by 5. The divisibility rule of 5 is if the unit digit is 0 or 5, then it is divisible by 5. In the given number, the unit digit is 0, so it is divisible by 5. Next we have to check whether the given number is divisible by 9. By the divisibility rule of 9, we have to take the sum of the digits of the given number. If it is divisible by 9, then it is divisible. The given number is divisible by 9. So here the sum of the digits of the given number is 9 and it is divisible by 9. So the given number is divisible by 5 and 9 both. Hence we can say the number 25,110 is divisible by 45. Question number 11. We have to check if a number is divisible by 6 and 4, then it is divisible by 24 or not. Question number 11. 18 is divisible by both 2 and 3. It is also divisible by their product 2 into 3 is equal to 6. Similarly, a number is divisible by both 4 and 6. Can we say that the number must also be divisible by 4 into 6 is equal to 24? If not, give an example to justify your answer. So we have to check whether the given number is divisible by 4 and 6 and then try to divide it by their product 24. If possible, we have to give the example. If not possible, we have to give the example why it is not. Solution. Here the given two numbers 4 and 6 are not coprime. So it is not necessary that a number divisible by both 4 and 6 must also be divisible by their product 4 into 6 is equal to 24. Example. 36 is divisible by both 4 and 6 but it is not divisible by 24. Question number 12. I am the smallest number having 4 different prime factors. Can you find me? Solution. We know that the smallest 4 prime numbers are 2, 3, 5 and 7. Hence the required number is equal to 2 into 3 into 5 into 7 and their product is 210. So 210 is the smallest number which has 4 different prime factors. Homework. Exercise 3.5. Question number 5. Write the smallest 5-digit number and express it in the form of its prime factors. Question number 9. In which of the following expressions prime factorization has been done? Question number C 17 and question number D 54. Today we have discussed exercise 3.5. Complete all the question and answers of exercise 3.5 in your notebook. For more detailed videos and textbook, please log in into the links of Diksha and Extra Marks.